Welcome. Today we're going to go through the Economizer controls from Siemens. Specifically, this is number 2 in the series of the video. We did the basics and configuration previously. You should probably watch that one first. Now I want to go through the advanced settings. This is stuff you won't tweak very often, but you should know how it works in case you ever need to tweak it. So let's get started. Before we go into the actual advanced settings screens on this Siemens controller, I did want to finish up a little bit something on the basic setup screens that is a little bit more confusing and more advanced, right? So we have the fan low actuator position for minimum ventilation, and we have the fan high actuator position for minimum ventilation. And we talked about those in the previous video. We said that you can have different for CO2 and multi-speed fan and all that stuff. The hard part though is that all of these minimum positions are not in CFM and they're not in percent damper open. They are in voltage, and that confuses a lot of folks. So I want to cover it a little bit. So right now I'm showing you fan low actuator position 3.6 volts. Right? And then the high one is 2.8 volts. So let's keep that in mind, and we'll go through this here. All right, so for standards, the way this works is these actuators go from 2 to 10 volts DC. That means 2 volts means 0%. Close the damper. 10 volts means 100%. Open the damper wide open. So for standards, the middle of the range is not 5. I know it's annoying, right? 6 is the middle, that's 50%. 4 volts would be 25%, right? 8 volts would be 75%, and all these increments in between. So that's one thing we got to keep in mind. So let's say the minimum position, let's say for argument's sake, I want this thing to be 10%, right? So what voltage do I set that for? 2 volts would be closed, 4 volts would be 25. So I know it's somewhere in between there. The way it works is that from 2 to 10 volts, that's an 8 volt span, right? And I want to go 10%. 10% of 8 is 0.8. For those of you guys that love math. I know like it's kind of a little bit weird and a little bit annoying, right? But I want to set that thing for 0.8. But it's not 0.8, it's 0.8 above the minimum. So 2.8 volts, that's 10%. So our default high fan speed was 10%. 3.6%, or 3.6 volts, excuse me, is another 0.8 above that, right? So 0.2 to get to 3, 0.8, so that's 20%. If I wanted 15%, that would be 3.2 volts. So instead of doing this math all the time, you may want to just make a chart like this once and never think about the math again, because most of us aren't here for the math fun, right? So 5%, that would be 2.4 volts. 25% would be 4.0, right? Like we said earlier. And you probably should never have more than 25% on a rooftop economizer, so it can handle that anyway. So if you kind of keep this in mind, or take a picture of that and save it, you don't have to really do this math ever again. But that's the way that works. The other piece of that is that people get a little messed up. Low needs to be a bigger number than high. People don't like that, obviously. The reason being is when I'm at low fan speed, I'm moving less air. So I have to open the damper up more to suck the same amount of CFM into the building. So if the fan speed slows down, I have to open the damper more. As the fan speed speeds up, I got to lower the damper down. So it always needs to stay inverted like that. Don't think it was wrong in the defaults or something. This number is always bigger, that number is always smaller for low and high speed fan. All right, now let's continue on with the real advanced settings. The next thing we want to do is dive into the category that's actually called advanced settings in the controller. So that's category 3. So I'm going to hold the button and scroll down through 2 and 3. Now we're in the advanced settings. The reason this settings group is different than all the other settings we did, like we did configuration, we did basics, right? This is advanced. The reason it's different is very, very seldom would you ever come into these screens and change anything. Like you could pretend it doesn't exist and you're fine on like 99% of the projects. But for those that need these screens, I'm gonna explain how they work here. So going through them here, the very first one is freeze stat. So by default, if there's a freeze condition in the mixed air, it's going to go to the closed position for the damper. If you want to go to only minimum instead of closed, you could. It doesn't really make any sense because chances are if the mixed air is that cold, you've already throttled back to the minimum. So it doesn't make any sense, but you could change it in here if you needed to change it. Stage 3 delay. So normally the thermostat calls for stage 1. economizer operates. Thermostat calls for stage 2, and then compressor number 1 turns on, and then nothing ever turns on compressor number 2 when we're in economizer mode. That's a normal sequence for every economizer for a very long time. What this allows you to do is actually turn that third stage on, and by default, it'll turn on 15 minutes after you've been calling for second stage. I don't like that setting. I would increase that to 2 hours. I know that sounds like a very long time. It is. It's long on purpose. The problem with 15 minutes, the default, is that within 15 minutes, it puts on another compressor, cools the building down, everybody's happy. That sounds good. The problem is no one knows compressor number 1 broke. So I need the 2 hours so the people in the space can feel a little bit of pain, a little bit of discomfort, enough to be annoyed that they call someone to fix it. That way they'll call someone to fix this thing in March or April when it's mild out instead of in July. If you wait till July and then you find out compressor 1's been broken this whole time and you really do need 2 compressors simultaneously, you're really in a bad spot. So I would always change that one to be longer. So you can see on here, it's already 120 minutes, even though the default's 15, because I've already changed it in a previous class. Actuator position, closed or open on a shutdown. Normally, when there's a shutdown, you want to close the damper off. That would be normal. If you had a weird project where you wanted to open it, like maybe you weren't using the shutdown input for an actual shutdown, you're using it for something else, some kind of weird manufacturing thing, and they got, hey, when we turn on these exhaust fans because we had a problem with our process, we had to purge a bunch of air, we also want to open up all the fresh air intakes at the same time. Okay, we can do that. We'll wire those into the shutdown input on the controller, but shutdown will really mean open everything wide up. Do the opposite of shutdown. So you can do that if you needed to. If you're going to mount the mixed air temperature sensor in an odd location, you can do that. Normally, you're going to have it in the mixed air position, which means it'll be between the mixing box and the cooling coil, or between the cooling coil and the supply fan. But if for some reason you want to mount it downstream, then you can do that. So that would be after the coil, would be LAT, leaving air temperature. So mixed air temperature means before the coil, LAT, leaving air temperature, means after the coil. And it just tweaks the sequence a little bit. So you can do that if you ever needed to. So for most jobs on a rooftop, like the little one we have here, you're mounting it in the LAT position. So I probably should change that here. Actually, I already previously have changed it. The default's MAT. I've already changed it to LAT in a previous class. LAT low and high, you can set a maximum and minimum on that. So if it's ever above or below that, it'll generate an alarm. So you can do that if you needed to. Defaults of 45 and 80 are fine. OAT sensor calibration, and then return air temperature calibration. So if your temperature is off by a little bit and you want to adjust it, you can. Honestly, I would argue that there's no difference between 57 and 58 degree outside air temperature, but if you are very set on making it exactly right, you can do that. You can go plus or minus 2.5 degrees to calibrate your device to match the actual thermistors you have in the system. So what you would do is, let's say your outside air was off by a little bit. Let's say it was 70 degrees outside and your probe said it was 72 outside. So you want to add 2 degrees to this. You would hit enter on here, and you would scroll up 0.5 degree, 1 degree, 1.5, 2 degrees, hit enter, and now we'll add 2 degrees to whatever the outdoor temperature sensor reads. So the 70 degree sensor now will display 72 on the controller. It'll control the 72. It'll match the probe that you have. And the same thing would work that way for return air temperature, mixed air temperatures, humidities. You can adjust those. Humidities are plus or minus 10%. Temperatures are plus or minus 2.5 degrees. MAT set point, the default for that is 53 degrees. So as the air is moving through the system, it's going to be 53 degree supply air, which is normal. Actually, 55 degree air supply temperature is normal for most designs. However, this is upstream of the fan. We assume the fan is going to add 1 or 2 degrees of waste heat, so we end up with 55. So that's why we have a 53 default here. But if for some reason you had a job that was not designed for 55 degree air in the duct, you would want to adjust this to accommodate that. So for example, if you designed a low temp system, 49 degree temperature in the duct, you'd probably want to make this set point be 47. It's not common at all, which is why it's in this screen, but you could do that if you wanted to. Antifreeze mixed air temperature set point. So the first setting I just showed you was whether the damper goes fully closed or minimum position on a freeze situation. This is the temperature at which it does that. So 45 degrees is the default. So if it gets below 45 degrees in the mixed air, we assume that it's a problem. we go ahead and shut the system down, or specifically shut the outside air intake system down. And then it's actually a kind of unique one, actuator tolerance. That one you leave alone. OAT lockout's a normal one that you would have. 32 degrees is the compressor lockout. So when they say OAT lockout, that's the compressor. 32 is kind of low. You might want to bump that up for most applications. You don't have to, but you could. I usually bump it up to 45. Which means below 45, the compressor won't run, and I'll do it with economizer only. If it's above 45, it can use the economizer and the compressor. So hopefully that gets you on the right track. Between the basics video and this advanced video, you should be able to fully configure one of these controllers.